goes up to 10.6 and minus 10.6. That's just because of how the design is.
Our project SmartCAN has two parts to it, hardware and IoT. In the hardware section, we had two sensors, an ultrasonic sensor and an accelerometer. And other parts of the hardware section included a servo which rotated 180 degrees, a buzzer, and an LED light. In the IoT section, we used ThinkSpeak and Twilio. These two go hand in hand in terms of sending a text message to someone. So ThinkSpeak extracted data from the Arduino, and then Twilio used that data to send a text message to a number that was specified in the code.
So the project we decided to do is called SmartCAN. So essentially what it is that it's a smart stick for blind people. Okay, so what we have is we have an ultrasonic sensor attached to a servo, and basically we did this such that it rotates 180 degrees of the blind person's view. And so what happens is that it beeps according to how far away an object is. So supposing there's an object super near, it's going to stop rotating and the frequency of the beeps is going to increase. Now if we move farther away, the beeps are decreasing and it will eventually continue onwards with its rotation like it's doing right now.
That's really cool.
Okay, so at night, we want people to know that there's a blind person on the road. So what we did is that we have an accelerometer over here that calculates the change in acceleration hooked to this LED at the very top. So when we move it, the LED is going to light up. We did that by using that Millis function to make a delay, and we checked the value before to right after. Yeah.
We have a button, and whenever the blind person needs help, he just has to click the button and it's automatically going to send a text message to a caretaker saying the blind person needs help. So we're going to show it to you. Come close.
So I'm going to press the button right now.
And here, that's the message saying caretaker help needed. Yeah.
There you go. The other thing we did is that we used something called I2C communication between two Arduinos. And basically what this does is that it gets the distance measured from this Arduino and sends it to this. They both act kind of like how Bluetooth acts, where this acts as a master and this one acts as a slave. So the reason we did this is that when we put it all in one file, we were having a lot of problems with delay statements affecting this servo. By separating the two, we allowed both of them to function properly and independently. Essentially, we decided to split our main code into two halves. The first half contains code for the ultrasonic sensor, the buzzer, and the accelerometer, whilst the second half contains the code for the servo.
This is our code for IoT. We use the SPI and the Wi-Fi 101 libraries, and then we listed all the variables needed for IoT to work. Then we set the button as our input, and then we try to connect to the Wi-Fi network. If it doesn't connect to the Wi-Fi network, this while loop will ensure that it infinitely runs until it's connected to the Wi-Fi network. If it does connect to the Wi-Fi network, it will print the Wi-Fi status and say connected to Wi-Fi. Then, in the void loop, we read the button value from pin 9 and set that value equal to val. And then we use a simple for loop that reads if val is high, print sending SMS and then send SMS to the number. This send SMS function is used here to send the SMS first to ThinkSpeak and then from ThinkSpeak to Twilio.